we talked about the normal distribution in 6.1, but we only talked about that in regards to a standard normal distribution. So when I say the words standard normal, what does that tell me about the distribution?
It's uniform.
So we did learn about uniform, but what about normal? Like if I say standard normal, the mean and standard deviation are always what? Yeah, so it looks like that. The mean is always 0, so it looks like that. The mean was always 0, and the standard deviation was always what? 1. That's a standard normal distribution. And so along that would be z-scores and such. In 6.2, we're still talking about normal distributions, but we're not looking at the standard normal. We're looking at other sets of data that have their own mean and standard deviation. So there's 2 ways to solve these kinds of questions. The first way is to standardize them, basically make them normal, find their z-score, then do normal CDF. And if we can recall from the last unit, how do we find the z-score of something? What do we...
The variable minus the mean over the standard deviation.
Yeah, so x minus mu over standard deviation. So value minus mean over standard deviation. So we can find its z-score first and then use normal CDF, where that's 2 steps, or we can just use normal CDF with the parameters given. So we won't just be using 0 and 1 anymore, but we'll be using whatever the mean and standard deviation is that they give us in the problem. So I'm going to show you both ways, and some people prefer one way over the other, but I guarantee you will probably like method 2 better because it's 1 step instead of 2. So let's look at the first example. It says, assume the heights of college women have a normal distribution with a mean of 65 and a standard deviation of 2.7. What is the probability that a randomly selected college woman is 6.2 inches or shorter? So I like to draw my picture first of a normal curve. I'm going to put my mean in the center, which is 65. And my standard deviation is 2.7. So I'm going to show you method 1 first, and then we'll do method 2 together. Method 1 would be finding out what the z-score is for the value that it's asking about. And what value is that? 62. So basically I want to figure out what's the area below 62. So method 1 is I'm going to find the z-score of 62 and then use normal CDF to find the area below that. So if I were to find that z-score, I would take what number minus what number over what number? Over 2.7. So someone with their calculator, tell me what you would get. Negative 1.111.
It's repeated.
Okay. And so if that's my z-score, using normal CDF, what would that look like to find the shaded area below that? I would say normal CDF. What would my lower bound be? If I want the area shaded below, negative 2 to the 99th. My upper bound would be, well, I'm using the z-score, so the negative 1.111, 0, and 1.
Can you remind me like how to get to the normal CDF again?
Second, vars,
Oh yeah, that's right. Okay.
and then option 2.
Okay.
It's like the lower bound and the upper bound. So if it's on.
So the lower bound is negative infinity, the upper bound is negative 1.11.
Wow.
Bless you.
And then you type in your z-score for the lower, and then upper you type.
No, I'm gonna type in negative infinity for the lower because it's shaded to the left because it says 62 inches or shorter.
Okay, I'm just trying to remember. And then the negative 1.1.
Mm-hmm. So what did you get for that shaded area? 0.13.
So there was an error.
3. All right, that is method 1. Find the z-score first, then put it in using 0 and 1. Method 2, which in my opinion I think is way easier, is just going straight to normal CDF and then looking at the lower and upper bound. The lower bound is still negative 2 to the 99th. My upper bound would be the value, which is 62. And instead of using 0 or 1, I'm going to use 65 and 2.7. Yeah.
Did we do the first method last time?
You had to do the first method last time because it was a standard normal. But this is different because it's giving you different means and standard deviations, like for a different value.
Wait, can you what would it look like if it was already set up normal?
It just has to specify that it's a normal distribution.
Oh, so it's gonna tell you?
Uh-huh. And the problem. It'll have to tell you it's normal.
Okay.
So it tells me 3 pieces of information. It tells me it's normal, it gives me a mean, and it gives me a standard deviation. And when you type this one into your calculator, you should notice that you also get 0.133.
That's just because when you're plugging in numbers, it gives you mean and then standard deviation as boxes to fill. So
Uh-huh.
you just change that.
Exactly. So method 2, like I said, is a little bit easier, probably what you would like to do. But I show you method 1 just so I can show you like the reason behind why it works. So 6.1 is just for a standard normal curve, and this is a little bit different. So if we look at number 2, it says find the probability that a woman is taller than 70 inches. And using method 2, what would that look like? Normal CDF, 70 to 2 to the 99th, and then 65 and 2.7. And so what do you get when you type that in? 0.032. Number 3 is now asking a percentile question. And so for this kind of question, what calculator function do I use? Inverse norm. So inverse norm, 0.75. And then I'm going to change my mean and standard deviation to be what and what?
It would be 120
And then 10. Good. And I always out to the side rewrite my mean and standard deviation just because whenever I'm grading these, like on the dual credit test, they ask or they look to check and see that you have your parameters written down somewhere. So even though it says it in the problem, make sure that you rewrite it out to the side. Yes?
What is it whenever you have to subtract to get like a different number? Like the last lesson we did it where
If it said like the top 25% or something like that.
oh, okay.
If it's talking about like an upper area.
Yeah, it's always.
Okay, so if
But if it just
25, then you do 75.
yeah, but if it just straight up says like this percentile, then that's the number that you put in. Anything attached to percentile is talking about that number.
Below 25.
You'd still do 25. If it's talking about below, but if it's like top, upper, something like that. Okay, what did you get for number 3?
126.745.
Perfect.
Yay, me too.
Very proud of you. Got it right.
She's a mathematician.
Hey, so why did I skip?
All right, try number 4.
56.052.
Oh, I did it. I didn't think that I did it, but I did it.
You did it. Whenever you see that P in front, that stands for probability. So find the probability that X is less than 8, given that you have a mean of 11 and a standard deviation of 2. So if it's asking for a probability of something, I use which calculator function? Normal CDF. And it says less than 8, so my lower bound would be negative infinity. Upper bound is 8. Then I put 11 and then 2 for my mean and standard deviation.
How do you know when to use normal and when to use inverse?
When
So
it's
if
about
it's,
percentile,
yeah,
you
if it's
use
talking about a
inverse.
percentile, that's inverse norm.
But if it's talking about like an actual value or a probability.
So what did you guys get?
0.067.
0.067. What about B? I would do normal CDF. My lower bound would be upper bound. And then mean and standard deviation are 11 and 2. And you get
0.383.
383. For part C, I would do normal CDF. My lower bound would be what?
Negative
62.
Because it says greater
Oh,
than. So 7.62 to positive infinity. 11, 2.
You got me.
What do you get for that one?
Oh, we got 0.954.
And then part D is written differently because it's giving me the percentile below and it's wanting me to find the value. So find X, which means find the value where,
Inversely.
yeah, so find the value where the probability is 0.025. So I would do inverse norm, 0.025, 11, and 2.
9.651.
Oh.
That's what I got.
Did you put 0.25 or 0.025?
Oh, I put 0.2.
That's why. Okay, so what is it? 7 point what?
Sorry, 080.
080.
Do we have to write left or no?
No. All right, the only thing that's not on here that could show up is what if, last thing, what if this sign where it says less than, what if that were a greater than sign? How would that change my area
Subtract it.
from 1? So I would do 1 minus 0.025, and that's what would go in the area.
I think we had that one.
Yeah.